Hey everyone, in this AP Chem series video, I'll introduce, explain, and give some examples of solutions. So far in this video series, we've learned lots of different stuff about the states of matter, solids, liquids, and gases. And in this video, we'll sort of keep doing that, but take it one step further as we talk about what happens when you start to mix different solids, liquids, and gases together. So lots of different things can happen when you start mixing different substances together. One of those options is simply nothing. A good example of this is sand and water. You can see in the bottom right-hand corner where this wave is pulling up some sand with it. These two things are mixing together, but not in a way where any actual process is really taking place. It's because the water molecules and the silicon and oxygen atoms of silicon dioxide in the sand, they can't really interact strongly enough with each other to really do anything, and the sand just sort of settles out to the bottom. There is a name for this, and it's called a temporary suspension. Other times when you mix things together, you actually get a chemical reaction to take place. A good example of that is a chunk of magnesium metal being added to a sample of hydrochloric acid like you can see here in this test tube. Since an actual chemical process is taking place, these atoms are exchanging electrons, rearranging, and forming new bonds and new compounds as they try to achieve lower potential energy states. And there's a third option that's kind of somewhere in between the first two, and that is that one of the substances dissolves in the other one. And a classic example of that is what happens when you add salt to water. Here you see some water being poured in the glass, and then a small teaspoonful of salt gets added. As the two substances are mixed together, the salt dissolves in the water. Here, those water molecules are strongly attracted to the sodium and chloride ions in the salt. That's what allows them to mix, and that's what allows the salt to dissolve. It's this third option that this video will introduce. So let's clarify some basic facts about solutions. First of all, they are homogeneous mixtures of two or more substances. Homogeneous simply means that the mixture is uniform. If you took a sample from the bottom of the mixture or the top or around the sides, each of those samples would have the same properties as the other. Dissolving is a physical process. That means when one thing dissolves in another, they are still the same substances that they were before. You do not create any new substances. There's also lots of different types of solutions, and some you might not regularly think about, like gases dissolving in other gases. That's essentially what air is. In air, you have oxygen and carbon dioxide and argon and other trace elements dissolved in the nitrogen gas that makes up most of the air. Weirdly enough, you can also have solids dissolved in solids. These are more commonly called alloys like brass or steel. You can also have liquids dissolved in other liquids. These are pretty common, and a good example is ethanol in water. We see this most often with alcoholic beverages like wine, liquor, or beer. The alcohol is ethanol, and that ethanol is dissolved in water. For this type of solution, there's actually some special terminologies that exist. Since the ethanol is soluble in the water, one of the words you might see is that ethanol is miscible in water. It simply means that the ethanol will dissolve. Two other liquids that don't mix, like oil and water, the proper way to say it is that oil is immiscible in water. You can also have gases dissolved in liquids. We commonly see this with soda. Those carbonated bubbles are from carbon dioxide gas that is dissolved in the water that makes up the soda. And then, of course, the one that everybody always thinks of, which is adding a solid to a liquid, and that solid dissolves like the salt water example we saw earlier. And there's other possible combinations of different states of matter creating solutions as well. These are just some of them. Make sure to pause and take some time to write down these key ideas. Let's close the video by clarifying that all solutions have two main components and some of the vocabulary that goes along with them. I'm talking about solute versus solvent. You can think about the solute as the substance that gets dissolved. This is not a super sciencey definition, but it'll help you understand and identify which is which. The solvent is the dissolving medium, and a helpful way to remember the difference between the two is by using the sentence, "The solute dissolves in the solvent." In the salt water we saw earlier, since the salt dissolves in the water, the salt is the solute and the water is the solvent. Make sure to take some time and write down these definitions. That also wraps up this introduction to solutions. Thanks a lot for watching, and here is a brief summary.